Okay, today we are going to be showing relationships in a coordinate plane. So we're going to be talking about situations that we can use the data for to create a graph. And we're going to be able to use the graph to look at those relationships. Okay, first let's look at an example. It says Marcy is purchasing carnival ride tickets. With each dime, she gets 3 rides. We must be talking about times long gone, right? So with each dime, she gets 3 rides. Marcy would like to know how many rides she will get with different numbers of dimes. So what we're going to do is we're going to take our information and we're going to put it into a chart. Now, in our chart, we have a row here that is the number of dimes. So for each dime that Marcy has, let's try to remember how many rides she's going to get. So if you look back in the problem, it says for 1 she gets 3 rides. Okay, now what if she has 2 dimes? How many rides will she get? That's right, she'll get 6 rides. What if she has 3 dimes? How many rides will she get? 9. And what if she has 4 dimes? How many rides will she get? 12. Now, you may have been able to do that in your head just like I did, but there is a way to do it mathematically. So if we think about the number of dimes as n, okay, n is just a mystery number. It's a variable. It's an unknown. N would be the number of dimes, and we know that each dime gives us 3 rides. If we were thinking of an equation for that, let's think about how we would do that. What we would do is we would take the number of dimes and simply multiply it by the number of rides. So if you think about our first example, if we have 1 dime, we multiply it by 3, of course we get 3. If we have 2 dimes and we multiply it by 3, which is the number of rides we would get, we would say, well, that's a 6, and so on. Now let's take our information and let's put it onto a graph. So as you can see, I have set up my coordinate plane. I have labeled my axes. So my x-axis is the number of dimes. So normally this first row is going to be your x and the second one is going to be your y. So you have to label your axes. That's part of graphing and that's a really big deal. Otherwise, no one knows what your graph means. So number of dimes is our x-axis and our y-axis is number of rides. Okay, I messed up a little bit. I didn't get enough in, so I had to extend my graph. You can see my y is embedded into my numbers there. So, okay, let's look at our first set. So our first set is going to be 1 dime is 3 rides. So if I were going to write the coordinate pair for that, I would say 1 dime is 3 rides. So the 1 is my x and the 3 is my y. So the second set would be for 2 dimes, and that would be 6 rides. So that would be 2, 6. So my x and my y. For the 3, I would say, okay, well that's a 3 dime, and I get 9 rides. And then my last one here is 4 dimes, and I get 12 rides with that. So those are my coordinates for my points. So our first one is 1, 3. So we're going to go over 1. So we're going away from the y-axis here. Over 1 and up 3. That's my first point. Okay, that's our first one. For the second one, we had 2, 6. So we're going to go over 2 and up 6. Okay, let's look at our third one. Over 3, up 9. We have 3, 9. Our next one was 4, 12. So we're going to go over 4 and up 12. Now, what we would do now is we would connect our dots. So this, of course, is called a line graph. And this is going to be a little awkward. I'm going to have to hold this down. Okay, now, cool thing about these is this is a function, so we're doing the same thing each time. Remember, these are like patterns almost. So when you have a situation where you're doing the same thing each time, you're going to end up with a straight line. So the more dimes you have, the more rides you get, right? What if we go down here and we extend our line a little bit? Look where it goes. If you have 0 dimes, guess how many rides you get? 0. So 0, 0 there, right? Okay, now let's go to our next situation. We are still at the carnival, and this time we decided we're going to play some games. So each game takes 2 tokens, and Marcy starts with 12 tokens. So she wants to know how many games is she going to be able to play before she runs out of tokens. So what we're going to do is we're going to think about an equation for this. So we're going to say, well, how many tokens did she start with? So the problem told us that she started with 12 tokens. So that's kind of like her total amount. And then as we go playing games, we're going to have to be taking away tokens for the games that she plays, right? So each time she plays a game, she uses up how many tokens? 2. And then you simply multiply that by the number of games. And then that will tell you how many tokens are left, okay? So we're going to use that formula here, that equation, to come up with our table information. So you can see I've set up a table here. We have our X and our Y, number of games played, and then number of tokens left. So let's use our equation. So if we had this first situation here with the 1 game, she starts with 12 tokens, right? And then we have to multiply 2 tokens by, she's only playing the 1 game at this point, okay? So, of course, in parentheses, we would do this portion first. So it would be 12 take away 2. So if she only plays 1 game, she's going to have 10 tokens left. So that would be a 10. Of course, the coordinates for this would be 1, 10. Okay. Now let's look at the second one. So let's say she keeps going. She plays another game. Okay. So again, 12. Take away, it's still 2. But this time we're going to play not 1 game, we're going to play 2 games. So let's think about what that would be. That would be a 4. So it'll be 12 take away 4. So that would be 8. So this, if she plays 2 games, she's going to have 8 tokens left. Let's do the next situation. So this time we're going to play 3 games. So we're going to start with our total tokens. And we are going to, it's 2 tokens per game, and we're playing 3 this time. So this, of course, would be a 6. So it would be 12 take away 6. So that would be 6. So fill this in, 6. Let's keep going. For the next situation, she's going to play 4 games. So she starts with her 12 tokens, and it's 2 tokens per game. Or 2 tokens. And then we're playing 4 this time. So let's see. Oh my, this would be 8. So it would be 12 take away 8. So that would be 4. Let's try the next one. So what did I say, 4? This time we're going to play 5 games. So we're going to say 12. Take away 2 tokens per game, and we're playing 5 of them. So this, of course, would be a 10. So that would be 2. Uh-oh, she's almost out of tokens. And then our last one that we are going to do, we're going to be down to nothing. Do you see that? We're going to have 0 tokens left. We're going to say we have 12 tokens to start. It's 2 tokens per game, and we're playing 6 games. So, of course, this would be a 12. So it's 12 take away 12. She's out of tokens. Nothing. Okay, now, so this would be a 0. Let's plot our points, shall we? I have my graph here ready to go, my coordinate plane. I have labeled Carnival Games is my title. I have the number of games down on the x-axis, you can see. And then on the y-axis, I did the number of tokens left. Okay, so this one's a little different because we're going down in the number of tokens for every game we play. So the number of games is going to go up, but what's going to happen to the number of tokens as the games go up? The number of tokens is going to go down for every game you play. All right? So, if you can think about it, your line's going to be a little different this time. It's going to be a straight line, but it's not going to be going in the same direction. Let's think about that, and then you're going to see it happen. So let's do our first set. We have number of games played was 1, and that means she would have 10 tokens left. So it would be number of games is 1, and there are 10 tokens left. So it would be 110. Okay, let's do our next one. If she played 2 games, she would have 8 tokens left. So 2, 8. Let's do the next one. We have 3, 6. So if she plays 3 games, she'll have 6 tokens left. 3, 6. And then if she plays 4 games, she'll have 4 tokens left. Can you see what the line's going to look like? So this will be 4, 4. If she plays 5 games, she'll have 2 left. So over 5, up 2. And then if she plays 6 games, she'll have 0 tokens. So this one actually falls right on the x-axis. Now, let's connect. I'm going to have that awkward moment again where I have to connect. Let's see here. You really can't go lower. I mean, if you go lower here, you're going to be down into the negatives, right? You're going to be like, Mom, can I borrow some money? Can I play another game and owe you 2 tokens? So you'd be down in the negatives if you were down in this area, right? So, and you can see this is kind of cool because look where it's going to head, right? If you had your full 12 tokens, you would have had 0 games. Okay, now look at the line. Do you see? As our games went up, what happened to the number of tokens? They go down. Okay, isn't that interesting? Okay, so the relationship there is like opposite. One goes up, the other goes down. On the one before, let's look at that relationship. As the number of dimes went up, the number of rides went up. So this was direct. So it was up, and the other one was like opposite. Okay, one went up, the other went down. So, okay, have a great day.